So, welcome everyone. I'm István Juhos, and I'm a senior Android engineer at TIR, which is a micromobility company in Europe. And we will be talking about how to test your Compose UI today. So, first of all, some formalities. If you want to just read along the slides or just skip a few of them, you can do that on Speaker Deck. If you go to my profile, there will be the slides on the first place, and there's also a direct QR code that you can use to go directly to the slides. Okay, I'll leave some time to scan the QR code. Okay, then we can begin. Okay, so a little disclaimer before we really jump into the topic. All of the example codes are taken from this small hydration tracker project that I put together for this presentation. It's really just a simple two, three screen hydration tracker application just for testing, Compose testing. So feel free to check it out. It's available on GitHub. Okay, with that out of the way, let's do a bit of a recap on how we usually do UI testing with the old AndroidView system. So with the old AndroidView system, we have views and view group objects that have attached rendering and behavior and some other things. And we create these views as objects, either inflated via the inflator from XML descriptors, or we instantiate them by code. Whichever way we choose, each of these view and view group objects will have IDs attached to them that we can directly reference them by, or either by just using their direct reference in the code. Okay, let's see. Okay. Sorry for the intermission. Okay, so let's see how that works in Compose. With Compose, we don't have direct access to the composition. We don't have direct access to the UI elements emitted into the composition tree. So yeah, that's what we have to think about. There aren't UI objects that we can manipulate. We have only functions that we can write that will emit those UI elements. Because of this, of course, we don't have IDs that we can reference by anything, pretty much. And also, while we can write many composables and nest them really deeply, not every composable actually emits UI into the composition. Some of them just emit, for example, layout information. So that's what we will be working with when we want to test Compose UI. So let's see what we will test in this short presentation. In the project, there is a composable called entry_list, which is just a wrapper around a lazy column. And the sole purpose of this is just to display a list of hydration entries by creating hydration items from them and displaying them as a list. The other thing that we will be looking at is a hydration item itself, which is just a wrapper around a row which displays two texts, which actually displays a hydration entry. Okay, let's see how we can set up tests with Compose. To start testing Compose UI, we will just have to add these two dependencies to our project, and we can start testing right away. Okay, how does a test look like? This is just a basic test that we can write. It's the orchestration that we need to do in order to test Compose UI. So we just create an entry_list test class, which is just a regular test class, and we slap the round with annotation on it with Android Unit 4. So as you can see, this will be an instrumentation test. And after that, we can just create a rule and get on with it. Before that, I need to mention this fabulous talk from DroidKaigi Berlin this year, where Jolanda Verhoef demonstrated that Compose UI tests can be run as not instrumentation tests, but UI tests. I really recommend you to look at this video because it's really informative. It's called Modern Testing on Android. Okay, let's get back to the actual matter. What we can do here is that we can create a test rule. This is pretty much an activity scenario rule that we can create, but with Compose there comes some extra helper functions that we can utilize. In this example, it's create Android compose rule, which will set up an activity for us. Actually, that activity can be provided by us, or we can just use a built-in one. That built-in one is called component activity, which is actually just a basic building block of the Android ecosystem. Most of the current specific activities inherit from component activity. This use case is where we only have a composable that we want to test and we don't want to access an actual specific activity. Then we can just pass component activities class reference into create Android compose rule, and we can just write tests for composables. There is a shortcut for this, and it's called create compose rule. If we just call this, then it will actually call, then this is just a multi-platform implementation of the create compose rule family of functions. On Android, this will actually just call the create Android compose rule with the component activity, so it's basically on Android just a shortcut for that. And with that, we have a test rule that we can work with. So it's time to create a new test. Compose UI tests are pretty much just normal tests that we would write anyway. They are just functions with some descriptive names, of course, with the test annotation put on them. Inside that, what we have to do is that we have to call everything and anything on the compose test rule, pretty much. So yeah, it just makes sense to use a scoping function on it, because we're just writing pure Kotlin code, so we can use whatever knowledge we have with Kotlin and whatever tricks we have up our sleeves. So it makes sense to scope to this test rule for each test. Okay, and then comes the next part, when we can call set content on our test rule. As I said, this now is the test rule. So we can call set content on it, and it's pretty much the set content that we are used to on activities or the Android or the ComposeView in Android. So yeah, this is our gateway to the Compose world in Compose tests as well. Inside that, we can call whatever composable we'd like. It can be a simple text. It can be a whole screen written in Compose. The point is that this is where we can define the composables under test. So in this example, we just add the hydration tracker theme, which is the theme of the application, and we just call the entry list composable with a preset list of entries. You might wonder where these entries come from, and it's really simple. We're still just writing pure Kotlin code, so this entries list is just somewhere around our code base. In our example, it's actually in the same file as the tests. But you can put it anywhere, you can share it between tests and so on and so forth. It's just Kotlin. Okay, so now we have some test code. We have the setup for our tests, but we don't know how to interact with our composables yet. As I mentioned before, we don't have a reference on the entries list that will be emitted to the composition. So right now we don't have a grasp on what and how we can test. So let's fix that. Enter the semantics tree. So what is the semantics tree? The semantics tree is a parallel tree that is actually built on every recomposition next to the composition. So it's a parallel tree that's used by the accessibility frameworks and by the testing framework. Some properties added to that tree can be only seen by the accessibility framework, some both, and some only for testing. So yeah, just keep in mind composables, as they can sometimes emit, sometimes not emit UI components. They might or might not contribute to the semantics tree by default. We'll see how we can change that as well. Okay, let's simplify our example a bit. So we have the test rule. We apply it on it, and we set a simple text in set content. As I said, everything can go into set content, whatever we want. So yeah, let's start with this small example. The semantics tree that this example will emit consists of a root node. Every semantics tree has a root node by default. And all other information, all other nodes emitted into the semantics tree will be children, direct or indirect children of this root node. So as you can see on the example on the right, we have the root node in blue, and we will see the actual semantics node in green in these examples. And text actually emits information into the semantics node by default, the semantics tree by default. So there will be a semantic node with the text property set to 100 milliliters in this example. Let's switch to the actual naming that Compose uses. So there is the root node, and there is the property of that new semantics node, which is 100 milliliters. You might notice that the 100 milliliters is with the array syntax. We will be touching that a bit later. Okay, let's add a row, because we are actually building the item view of our application. So if we add a row around the text, nothing will change in the semantics tree. That's because layout composables, like row, column, box, and so on and so forth, by default doesn't emit anything, doesn't contribute to the semantics tree. They only emit information into the composition as layouts. So the semantics tree in this case won't change. Let's add another text, because we have two texts on the items that will contain the current date. And as you can see, the semantics tree will contain those separate text nodes as semantic nodes with the proper text. Okay then. So now we know that something is happening in the background. Not just the UI building, but there is a semantics tree that is building in the background. So how can we visualize proper semantics tree when we have very deep nested composables that we want to test? Okay, so we can visualize the semantics tree at least two ways. One is in tests, we can query and print to the log representation of the semantics tree. If we use the onRoot finder and we call print to log on it with the log tag, then we will get this representation in logcat. Of course, the tag serves the purpose of finding this logcat among the sea of other logcat messages. So yeah, this log is actually a structured log that has the same structure as the semantics tree that we have. So there's the root node without any extra parameters, because it's just the root node. And in the log, you can see the two text nodes emitted by the two text composables. As you can see, there is the text property again, and there is also some extra information there called actions that we will touch a bit later. Okay, the other way outside of tests is just to use the layout inspector in Android Studio. If you run a Compose screen on your device or emulator, you can start the layout inspector, and if you enable highlight semantics layers option in the visibility options, then the nodes in the composition that actually emit information into the semantics tree will be highlighted with white, and the rest will be grayed out. And if you look at the attributes panel, there you can see what information is emitted by that node into the semantics tree. Okay, let's see how we can modify the semantics tree and the behavior of composables regarding the semantics tree. There is a useful modifier that we can use for this. It's called Semantics. By default, it doesn't do anything. So if we just add the semantics modifier onto a node, onto the list of modifiers of a composable, nothing will change. So for this example, we'll have this tree. But as soon as we start adding some information to the semantics modifier, for example, the content description, the graph changes like this. By default, row didn't emit anything to the semantics tree, but by the semantics modifier, row will actually do it, will actually emit to the semantics tree. So in this example, adding the content description property creates that semantic node. Now row has its own semantic node in the semantics tree, and the two text nodes will be the children of the row, as we would expect. Okay, also, just note that content description is something that accessibility services use most of the time, but it can also be picked up by the testing framework. So we can assert and we can find a node by that, and so on and so forth. In contrast, if we set the test tag property among the other available properties, the test tag will actually result in a property named tag, and that is a text property as well. And that won't be available for the accessibility framework, but will be available for testing. Okay, let's get back to our actual implementation of the item. As you can see, there's a row and there are two texts. Now we don't have that modifier on the row, so we're back to square one. So let's add semantics again. And as you might notice, there is a parameter called merge descendants in the semantics modifier, and it's false by default. So this is another way that we can use to modify how the semantics tree is built. So if merge descendants is false, then that node, if a node is created, don't do anything. Their children will be untouched. They will be emitted into the semantics tree as is, as defined by them. But if we change it to true, then this row will actually contribute some information again to the semantics tree, but it won't create a new node. But on the other hand, it will merge its children into a new merged semantics node. And as you can see, this is where the arrayness of the properties come in. So if we have a merged semantics node, then the array will actually, in this example, the text will actually contain multiple strings. That will have some importance a bit later. Also, there are some built-in composables that do the merging by default. For example, the button, the simple button, merges everything, every part of its child hierarchy into one semantics node. So even though we see a button here with a text child, the whole semantics information this button will emit into the semantics tree will be just one node. As you can see, there are multiple properties that the button adds to the semantics node. The most important is there is the text already merged into the semantics node, and there are some actions that we will touch a bit later. Okay, so this is another way that we can use to modify the semantics tree, the semantics information emission, and it's clear and set semantics. So if we call this on a modifier, then all of the actions that a composable would take to make a semantics tree sane will be deleted. So there will be nothing. There will only be just one node that will be created, and it will have the information that the semantics information here is purged. And in the block of clear and set semantics, we can add some extra semantics information that will in fact override everything that the button in this example would emit. Okay, so just don't overuse it. Careful with this. Okay, so now we have some grasp on what's in the composition by using the semantics tree. So we have some representation of what will be displayed on the UI. So let's see how we can exercise and assert on these nodes. So first of all, we've already seen this. On root selects the root node, and we can call print2log among some other functions on it. So yeah, it's pretty much it. So root doesn't have much power here. But we have other finders that we can use that can select nodes. There is the onNodeWith family of functions that can select exactly one node. So if they don't find a node with the given properties, then that will be an error. An error will be thrown. So the onNodeWith functions can select based on multiple properties. For example, the onNodeWith tag tries to find a node that has the tag that we provide. So in this case, that middle node has the tag of list item, and we're looking for that. So that node will be selected for testing by this function. Of course, we have some more of these functions. onNodeWith content description tries to match the content description, and onNodeWith text tries to match for the text. Okay. Also, there is a trick that we can use that's related to the merged and unmerged semantics tree we already touched. So by default, all of the onNodeWith, and for that matter, the onAllNodesWith functions, there is an extra parameter that we can add, which is the useUnmergedTree, and that's false by default. So if useUnmergedTree is false, then the lookup will happen on the node, on the tree that's actually available, that we emitted into the semantics tree that the composables do. But if we set it to true, then all of the nodes will be available that would be available without merging the semantics tree. So if you have a use case when you actually want to test some sub-components, that are there but actually not available in the merged semantics tree, you can do that as well if that's what you're looking for. Okay, we already touched the onAllNodesWidth functions, which are pretty much the same as the onNodeWidth functions. They can just select multiple of the matching nodes. So for example, if in a list, if you want to select all items with a test tag and the item composable has a certain test tag, then you can get all of those semantics nodes relating to those composables. Of course, the onAllNodesWidth functions throw an error if there are no nodes that can be found, given the criteria. We can also write our own matchers, just as in Espresso. So if we use some matchers multiple times or very often, we can just combine them and give it to onNode. So next up is actions. Now we can select nodes in the semantics tree, and let's do some actions on them. There are the basic actions available in the Compose testing framework, like click, scrolling, text input, gestures, key presses, and so on and so forth. So let's see an example. Here is a humble button with a text of 100 milliliters. We can select it by onNodeWidthText. It will be selected. The onNodeWidthText function will return an abstract node that we can call other things on, and we will call perform click on it. And it will work. The button will actually be clicked on the UI when we run this as a UI test. This is actually possible because the button, as we've seen before, declare the onClick action in the actions of its semantics node. So the framework sees this and says that, okay, this is a clickable button. It's fine. We will click it. Okay, so, but because onNodeWidthText returns a generic node representation, we can actually call perform text input on the button. And I'll try to do this interactively. What do you think will happen? Hands up if you think that this will not fail. Just silently say that I can do this, and the test will actually just move on. Anyone? Okay, the other thing is that it will fail. It will throw an exception. So yeah, because nothing voted on the first one, the second one is true. So if you try to do this, we can do it. The compile time, we won't get any errors, but runtime, when we run this test, this perform text input will actually throw an error, because the node didn't define the setText action, which a button shouldn't define, so that's okay. So actually this will account for the correctness of our UI as well. Okay. There are a lot of more APIs that we can use, and there is a cheat sheet for that. We don't have time to look at every one of them, so just please refer to the Compose cheat sheet in the official documentations. Okay, let's see some techniques on how we can structure our composables and what can we think of when we are creating them to make them easily testable and make our lives easier. First of all, is a good tip, structure your composables with testing in mind, and also try to make them as little as possible and as reusable as possible. Because, of course, that saves time and energy. So for this project, there is the entry list composable, which is quite small. It's just a wrapper around the lazy column. And yeah, so by itself, it really doesn't have much attached to it, much behavior and much data going on and so on and so forth. So it will be easily testable. Where it lives is in an entry screen composable, which is in fact the view model holder or the state holder. So this is kind of cumbersome to test because we have to mock the view model. We can do it with HILT, of course, which is pretty easy, but still we have to mock it, and that won't be that pure Compose test that we're striving for here. What we actually can do is, if we have this entry list as an isolated composable and really small, then we can live with the assumption that these building blocks of this screen will actually just build the screen altogether. So if we don't want a full integration test with a mock view model and so on and so forth, or a mock network behind the view model and so on and so forth, we can just test these composables in isolation and make our UI tests, well, composable as well. Okay, so the testing for this small entry list composable would look something like this. The setup is pretty easy. We already seen that. And for this short test, we just select the entries list composable, which will be there because we declared it. And we can just call the onChildren on it, which will return all of his children, and then we can assert that that list of children has actually the same size as the entries. So this composable is pretty easily testable. Okay, another thing that composables can have is behavior. So testing behavior is a thing, and we should be looking out for it. In this example, we have this cluster of 3 buttons, which have predefined values that the user can add daily consumption with. So there's 100 milliliters, 250 milliliters, and 600 milliliters button, each defined with its own composable. And this whole cluster of composables just can just communicate a value to its parent. And each of these buttons call this function with a different value that should be added. Okay, so how to test this? There is a pretty easy way to do it because we're still in just pure Kotlin. So if we just create a variable outside of the whole testing but inside the test, and we fake that callback that this composable gets, then we can just set this value outside of the composition, and this will live there because it's part of the test. So if we set this, we can perform a click on any of these. In this example, we click the 500 milliliter button, and we can just see if the fake callback was called and the correct value was passed when we click the correct button. Okay, let's continue with the interesting part. Let's see how we can test hybrid UIs. So first of all, what are hybrid UIs? Hybrid UIs is when you mix and match Compose and the view system views in one layout or one composable where you add an Android view and so on and so forth. Okay, of course, this spawns the question that, okay, now we see how we can test Compose, and we know how to test Android views because we have Espresso, but how can we combine those two into one? So let's see some examples. The first way that we will see is using a ComposeView in an Android layout, in an Android view layout. So the example is pretty small. We'll have a toolbar, and we'll have a button that will actually be Compose, because yeah, it was, for example, imagine the situation that you're already switching to Compose in your project, and it's easier to implement a fancy button, an animated button, for example, and add it to the existing screen than to rewrite the whole screen in Compose, of course. So yeah, we will have this layout, a constraint layout that has a toolbar, which is just a normal view, and then we can use Compose interoperability to add that fancy new composable button into the view with ComposeView. So this is just a simple view that can host composables. Okay. Also, we need some binding code for all of this to work, which will be an activity in this example, but it can be a fragment as well, or just another view. In this example, we'll just use view binding to bind all the things together. So in onCreate, we create a binding, we set the content to, and then we set up the toolbar. We'll just need to add a title to it, and then we can set the content on the ComposeView, which will be our fancy custom button. And the layout that we'll end up with is on the bottom right. Okay, so how can we test this? We'll just write a simple test class as before. We'll create the compose rule, but there we'll just add the ComposeView demo activity, our activity, as a parameter of create under compose rule, so that this rule will start that activity that we've just seen before. Then we enter the test, and inside these tests, we have the Espresso object, which is our gateway to Espresso. And from that, we can use any Espresso API that we're used to. So as you can see, there's the onView, there's the check, there's the matching, and there's everything that's Espresso. So this is the interop between Espresso and Compose. And of course, we know that this layout is a hybrid layout, and Espresso works on it. This test will pass. The toolbar is there, and it's displayed, so this will pass. And then we just continue with a simple visibility check in Compose. And may I remind you, this is the same test. So we can mix and match Espresso and Compose testing in the same tests, and it will work. Let's see the other way around. Now, we started a screen in pure Compose, but there's a really fancy button. We made really a lot of effort to make it work in views, and we don't have the time and energy to refactor it to Compose or to rewrite it. So now we start the screen, but we want to include that fancy button. That's still in views. Okay. It's nothing special, actually, the fancy button in this example. The extra thing that it has a set text and it has a set on-click listener that we will be using just for example. Okay, and the host of this is just a composable, so no activities, no views here. This composable just receives a click listener, and it builds a scaffold with the top app bar configured, and then adds an AndroidView, which is the interoperability API for the other way around when we want to include views in composition. Okay, so we will just create that custom button view, set the text, set the click listener like we would do normally from AndroidView system code, and yeah, we can test this layout as well. So the rule for this is just created by the simple create compose rule, because we actually don't need a specific activity for this. It's just a pure composable, well, pure as it can be with that custom view inside it. So we just set the content as that AndroidView demo composable, set a click listener to it with that behavioral testing that we've seen a few slides ago, and we can move on to actually exercising this code. Okay, here are the tests that we will do. First of all, we'll see if the title part, the Compose title part, is there. It's there. This test will pass, or this check will pass. Then we check the visibility of the view inside the composition. It will pass. Espresso works just as we expect it to be. And there will be a bit of a problem when we'll try to click the button from Espresso. And actually, this is a bug in the framework. So yeah, as of Compose 1.3.0 beta 3, there's an issue with the clicking mechanism in Espresso, and it won't work, unfortunately, with these kind of hybrid UIs. You can check the issue tracker thread on this. Unfortunately, it's been around since 1.2.0 alpha something. There is a kind of unstable workaround for it, and that's using the callback of the check method of Espresso. The only problem with this is that sometimes it won't work because that click, that view.perform click, doesn't happen in the context of Espresso. So it might be performed after a check is done or before a check is done. So it might make us write unstable tests. So I'm not recommending this at this point. Anyway, if we put that in our test, the assertion on the end might or might not be successful. Yeah, that's what we have to work with now. Okay, we are nearing the end. So I listed some other topics to check out on Compose testing. So testing animations, we didn't have time for that here, but it's actually a really interesting topic that has many documentations. Yeah, we have in Compose we have this clock that we can manipulate when testing animations, so on and so forth. I won't talk more about that, but it's an interesting topic. Also, because in Android, composables are actually hosted in an Android view of some sort. We still have to tackle synchronization and idling resources in the real world, in real applications. And of course, we will have to look into screenshot testing as well. There are many tools for that purpose now. There's Paparazzi, there's Showcase, and a few more that I don't mention here. And actually, if you want to get more involved in that, tomorrow at 2:05, there will be a talk about it by David Vavra. Sorry. Okay, I listed some resources that I used to make these slides and to make this presentation, so feel free to check them out. Most of them are the actual documentation of Compose testing, but there is a link to an episode of Android Developers Backstage. Check it out, it's a really good episode on Compose UI testing. And there are some YouTube videos as well. So yeah, check them out if you have the time for it. So, summing everything up, let's see what we've learned in the last 40-ish minutes. So, UI testing in Compose can be done by utilizing the semantics tree, or of course the screenshot testing. And also, if we plan for accessibility, that means automatically that we can test our composables well. So if we create proper semantic nodes, we treat composables as one semantic unit where it makes sense. That helps with accessibility just as well as testability if you're writing Compose. Okay, testing composables in isolation and making them as little as possible really helps UI testing and really helps to make our composables well, correct. Also, if you're at the stage with your project that you're getting used to Compose or just writing some views in Compose or rewriting some views, then hybrid UI testing is pretty much supported with some minor flaws. But if that's the only thing that holds you back from creating hybrid UIs, there's not much to fear about. With that, thank you very much for your attention, and have an awesome day. I will be around for questions. ありがとうございました。